today's lesson is on triangle congruencies and how we can show whether or not two triangles are congruent or not. So there's a bunch of different theorems that we'll go through, 7 of them. Angle, angle, side, 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 angle. So you'll have to look at a pair of triangles and then figure out which one of these and one of these. So I've found a pretty good website that gives us a visual explanation for these. So let's go there. And I will give the link to this site. So the first way is 3 pairs of congruent sides. Now, congruent means that they are the same measure for segments and also for angles. And then for triangles, it has all the same measures for the sides and all the same measures for the angles. So I can move this one, right? Whatever angle I want works, but the side lengths are all set. And there's really only one spot where those align, and that makes a congruent triangle. So for side, 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 here it is. So side, side, side can be. Okay. Now let's go back. And now we can check on the 3 pairs of congruent angles. So the angles, those I can move however I want. Excuse me, the sides lengths can change, but the angles themselves are fixed. All right, and as you can see, as I move the angles, the sides lengths change, even though all 3 angles are remaining, right? 30, 100, and 50. So angle, angle, angle does not prove congruency. There's similarity, but that's not what we're talking about right now. For congruency, all the angles and all the sides must be correct. So for side, or angle, 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 cannot. I pulled that up on accident. All right. Side, angle, side. So I have a side, an angle, and then another side. And notice that the angle is between those 2 sides. So I have this angle over here and this angle on top. Both of those can change, as well as the distance. Right? But if I'm going to complete the triangle, the only way to do that is by going straight across, right? This 7.3, that distance is fixed. 3 is fixed. The angle between them is fixed, so I can change nothing on any of this. The only piece I can change is this here. And the only way to make the triangle is there. So for side, angle, side, why does that keep popping up? Side. It can. To the next one. Hypotenuse leg. Hypotenuse and leg is only for a 90-degree triangle, and the height of this triangle can change, but the hypotenuse, the leg, and hypotenuse, leg, a right triangle really just means it's an angle and two sides, but this is specifically a right angle. So I can change the angle however I want, and it intercepts the other line at that same height. So hypotenuse leg can keep pushing buttons. Side angle, so two congruent sides with a congruent angle not between, which this is kind of similar to the hypotenuse leg because the angle is not between, but this was specifically a right angle. For side angle, we do not know that this angle here is 50 or not. So I have an angle that can change, well, two angles that can change. But notice I can click, okay, so here, so it kind of looks like I can just only do one triangle. But there's a second one right there, which definitely not. So side angle does not work. Side angle. Next one on our list is Anglesideangle, two pairs of congruent angles with a congruent side between. All right, so 7 is my between, and then the two angles are 35 degrees and 65 degrees. So, yeah, I can change the side length, but they always are going to intercept, right? They're very much forced to intercept in a single spot, right? There's no movement I can really do if I've got angle, side, and angle. Angle, side, angle is a yes. So our last one is angle, side. All right, so I can move back and forth. Because my bottom length is not determined, and this angle is, or excuse me, this side length is also not determined. Right, but with all the wiggling, there's only one spot where those actually connect and form a triangle. So angle, side. Can be proven. So we have two cannots and the rest are all ways of proving. So hopefully this gives you the tools you need to understand how to go through today's lesson. Good luck.